right, good afternoon, everyone. We're here to talk about Intro to Building Data Pipelines in Python with Luigi. So, hope everyone's having a wonderful conference so far. And I know we know how to say hello at Pi Gotham, so hello. My name is Adrian.
Hi, Adrian.
And my slides aren't switching. There we go. So, all right, so data pipelines is essentially you're taking some sort of X, maybe transforming it to Y, and you're going to get Z. And we're going to be doing it with Luigi. So, Luigi. All right, so maybe not this guy, but this Luigi. Luigi is a project that was open sourced by the folks at Spotify in 2012. Anyone from Spotify? Yes. I have nothing wrong with Spotify, but part of my talk I said, if there's anyone that's from Spotify that's coming to this conference that want to do this talk themselves, feel free to do it. But, so, no one's here. So Eric Bernardson is one of the maintainers of this project. He worked at Spotify, but is doing a startup now. It's now being taken care of still by him, Elias Frieder, and Arash. So let's take a look at what is Luigi. So Luigi is a workflow engine. It helps a lot with dependency chaining, and really just is the glue between taking some sort of data source and to some sort of transformation and all the fun big data stuff in between. But to quote the Luigi project themselves, Luigi is a Python package that helps you build complex pipelines of batch jobs. It handles dependency resolution, workflow management, visualization, handling failures, command line integration, and much more. So you can read more on the Read the Docs page. And like I said, they open sourced it. There's their GitHub. So why use Luigi? And for that, we're going to take a look into history, how we used to do it back in the day. Not that far back in the day, but let's look at our bit data pipeline again. I've added a little bit more detail on what these little tasks do. So let's say we're fetching data in the first part. We're going to aggregate, and then we're going to load that new updated aggregate into some new database. So we're going to have some sort of file, let's say fetchlogs.py. It's grabbing, in my example, so log files that we could store locally so we can then aggregate on it. So aggregate logs.py does its own aggregate. So quick example of some sort of aggregate, you're taking, let's say you're taking web log files and you want to take the frequency of URLs. You're kind of compiling a most popular list. Let's say I used to work at about.com, so maybe what's trending now, or the most popular articles right now, you could calculate something like that. And then our load data.py, it's obviously taking that new updated aggregated data and then kind of storing it into a database. So how we used to do this in the past was you kind of use this in some sort of those three little things, and you kind of do it in a scheduler. In Linux, or the other, that's the Kron guessing game, I like to call it. And it's the Kron guessing game basically because you're going to schedule one job, let's say at 11 o'clock. Fetchlogs.py runs at 11 o'clock. And you know that it kind of finishes in about 45 minutes. So you're like, okay, so let me schedule the next one an hour later. So aggregate logs runs at 12. Excellent. And you know that one pretty much runs more or less the same, around 50 minutes. So you're going to schedule the next one at 1 o'clock. So excellent. Great. Everything runs perfectly fine the first time. Wonderful. But so what happens when something fails? So this is our full data pipeline in all its process. But what happens when something fails? So if one of these things fail at all, you're going to have the entire process. It's crap. So consider a download failure from your log files. So for whatever reason why your log files could not download from your server, the internet went down, the server burned down, the data center burned down, something happened. There's no data now to process. But the process still continues. So your aggregate logs job tries to run, but guess what? Fail. There's no data to aggregate. And obviously the load data job tries to run as well, and that obviously didn't run because aggregate logs failed as well. So fail again. So how can we solve all of this? So I kind of just said that, what if the log files, in my example I said web log files, maybe there was a lot of traffic that day and your log files are huge and they're just taking a really long time to download. So okay, it took maybe an hour and a half that day. So that's why your consecutive jobs failed. So let's add more time between cron jobs. That's kind of hacky. It's not really a solution. So, okay, let's think about something else. What about we write a wrapper around all jobs? Okay, that's decent. Sounds like something we can do. So let's take a look at a generic pipeline wrapper. So this is how we could generally do it. So we have import OS, so we're checking for a file. We're fetching logs and aggregating logs and loading data from all those previous files that I just had. So if we look at def main, so data download, let's say it returns the file that it writes out to, or it downloads. And then, so we have a couple if logic blocks that is now saying that, is the data here? All right, then you can do and calculate your frequency. And then calculate frequency, let's say it returns the frequency file that it will write out. Then there's another if logic block that then you can write the data loader. So it's okay, it kind of works, but you can do this better, so please don't do this. So let's take a look at our cron game, revisit it. So it's at least now looks like this. So you have one job, it just runs once, it's in your wrapper. Excellent. So now we can dive into Luigi way. So in Luigi, you have things called tasks. So let's take a look at our fetch logs task. So we're going to import Luigi, and I purposely left out implementation of these methods, but we're going to get to those later. So in Luigi, you subclass a Luigi task. So Luigi task is essentially what those three py files were. So here we have a fetch logs task. It requires that you have an output and a run method. So our new aggregator task, it more or less looks the same, except you can, this is going to have you override the requires method. So once again, I left out the implementation just because I'm going to get to that later. So our no data load task will be defined in a bit because that has a lot more in-depth to it. So let's take a look at the task methods first. So like I said, this is the output task. So Luigi has a concept of targets. So here, a local target is really just something on the file system. In Luigi, a task is defined as complete, as something that has output. So whenever a Luigi job runs, it's going to go and say, hey, is this output exist? Then it's complete. So tasks that do not have output can override complete if you wanted to. So if, let's say, I have an email task, and I don't want to write out a file or write to a database just to say that, I sent that email already. So you can override the complete method just to make sure that it says that this was complete. So let's take a look at targets. Like I said, a local target is a local file. So it's really just a very simple local file. Luigi can write to it. Let's take a look at does anyone use Hive? A couple folks. Excellent. So Hive sits on top of Hadoop, and it gives you a nice HQL language that you can kind of query about. So the Hive example kind of looks like this. Here we're creating an output that is essentially a Hive partition. So if you wanted to kind of load data into a Hive partition, you would want a Hive output. So this is what this would more or less look like. And let's take a look at requires. Requires is, like I said, it's handles a lot of the dependency chaining, and it's very important for that. And really simple. It just returns a list of whatever dependent task needs to run. So this is how we define our dependency chain. So now let's take a look at, yeah, so these need to be run. So it's a kind of backwards dependency thing. So correct. So whatever you have in requires needs to run before this task that it defines requires. So now let's take a look at the run method. Run method is obviously just where you're going to put the bulk of your logic on whatever task you're doing. So here, let's say that it's opening some sort of input CSV file. It's splitting it, and it's going to get the number of times that cat is written in it. So very simple, very very dumb, actually. So very similarly, let's take a look at the run method for let's doing a job on HDFS. So just a quick plug. Spotify also open sourced their Snakebite HDFS client. It's really nice. And it's actually built into Luigi as well, so that's nice. So the HDFS kind of a run method, this is basically copying files to HDFS. There's nothing very out of the ordinary there. And right there, you can see towards the bottom, we're writing out to a file just to say that, that this job will be done after it's done copying the files to HDFS. So now let's go back to our original example. So copy logs is going to look something like this. It's going to have some sort of output that you could say, hey, I'm done copying these files. And obviously, your implementation depends on what you're copying from. So it has native support for S3. So in the past, I've copied files from S3 just to work on them locally and then do some aggregation and then push them else somewhere else. So aggregate logs kind of looks like this. You are taking some sort of data. It's the same cat type of example again. And it has a requirement that you are, that copy file ran. So copy file will run before this runs. Let's take a look at our load data. And so this is why I left out the implementation of the data loading before. So this does not subclass a Luigi task. It actually, and this is a Postgres example. So this has a different implementation for different databases. They have MySQL support as well. But this is just for Postgres. So it just kind of requires that aggregator task runs, and then it'll load all that data into Postgres. So let's go back to, let's go to a kind of real-world application on what was done. So like I said, I've done fetch logs from S3 before so that we could kind of do some metrics on that. So we were doing CloudFront logs just to get general web data. So we kind of had to clean them up. That's the second job. We load those raw logs now into HDFS. We're now able to create a Hive partition. And we also want to do a little small metrics just to kind of give us a baseline email on how the traffic was that day. So what Luigi is not. So if you're looking for a cron replacement, that's not what Luigi is. So you're going to have to use some sort of scheduler. And to kind of quote the Luigi project themselves, they kind of say that for running tasks periodically, the easiest thing to do is to trigger a Python script from cron or from a continuously running process. So it's not here to replace cron at all. But a quick note, Luigi does have a central scheduler that works concurrently with it. And it gives you these nice, fun little graphs about what kind of pipeline jobs are running. So if you have tons of jobs that run, this is an example from the Luigi documents itself. I don't do anything this extensive. So it kind of has a dependency chain and says, which way things go, and it's pretty neat. It's nice to see that you could kind of just look into a web GUI and see how you're doing. So let's look at more on what Luigi is not. So it's not here to replace Mr. Job. Yelp open sourced their Hadoop client, so that's Mr. Job. So it's kind of just to work concurrently with it. It's like I said, Luigi is the glue around your data processing. And it is also not there to replace scalding. So anyone using scalding and Scala, it's really, I know what scalding does. It's not there to replace scalding, but there is actually support for it. So things that are not covered in this talk, I briefly talked about that there is MySQL support, so if you want to take a look at that. Any Pig users, it does support Pig, Redshift, Spark, BigQuery, and a couple of things. I actually just saw a pull request to have Salesforce integrated into it. So if anyone happens to be using Salesforce for whatever reason why, it does have support for Salesforce. So take a look at read the docs or Snakebite. They are fun, riveting information. And if you want, there are also projects very similar to Luigi. So there are just two that I know of. I'm sure there's a couple more, but these are two main ones that I know of. Airbnb just open sourced their Airflow in June. So it's a very similar model, dependency chaining and workflow. And Pinterest did Pinball. And that's all I've got. And so I was told to put in some fun slides about Mario and Luigi. I've got a little more time to take a look at more code, so hopefully we can get to that. But I'm an engineer at Teachers Pay Teachers, and we're hiring. You can see the job page there. The slides are online. Now let me get to, how much time do we have, Juan? Excellent. So I could do a quick demo. Well, not demo, but bigger example. It opens. Presentation mode. All right, so this is actual code for pulling down logs from S3. Just a very simple example. So there we go. We can obviously do a bunch of regular Python things. Boto is used here. This is old code. So like I said, I kind of made S3 task-based because I knew I was going to do a lot of subclassing around S3. We have some sort of S3 bucket, and then this handles general code around that. So the logic, here we go. So I've written out a temp output because I'm copying down a couple of files. And we can see here that you could actually do requires that are not Luigi jobs. Here I have a small wrapper around os.makedir. So, excellent. And our run method kind of looks like this. So we're just kind of going through S3 and getting all the keys, and then you could write output very similar to that. Let's exit. Presentation mode sucks. And people using Hadoop. this. There we go. This is more or less what a Hadoop kind of job would look like. So very similar thing. I took HDFS task base to make a class so I could make smaller subclasses and make it more object-oriented. It has this complete method I overrid because we're doing some custom logic here. But, like I said, complete, all it does is it returns true or false just to say that, this job finished completely. So the output for an HDFS job is a local target just to say that, it written to it. But if you kind of want to write to HDFS itself, there are things like HDFS targets that you could write locally directly to it. And here, our requirements was really just our S3 copy job that I just showed you, so that this job won't run before S3 copy because S3 copy is its requirement. And so here's our run just for HDFS copy. So HDFS copy just kind of has logic to do things like clean up the directory. This is very specific to what I was using it for, but it's really just copying files to HDFS so I could do some MapReduce on it through Hive. Excellent. So I've got 1 minute. I hopefully can get to this. So back to the way jobs run. I said it runs in a backwards type of dependency. So you kind of want to write wrappers around the last. So if load logs is my last job to run, I want to call that. And then it'll say, go down through its requirements dependency chain saying, okay, this requires this task 5 to run. And then task 5 requires task 3 to run. And then task 3 requires task 0 to run. And then task 0 can finally run because it has no requires. So that's how we handle a lot of the dependency management through Luigi. And that's pretty much all I've got. One thing, there is a way to kind of just run concurrently with other things. So if you can just, you can do things like add tasks to your workers and just run them within Python itself. So I think I'm out of time. Well, one, said definitely I'm out of time. Thank you, and have a good day.